The National Electrical Code, or NEC, dictates how electrical systems should be installed to ensure safety and proper operation. One common area of interpretation involves the distinction between service conductors and feeders, especially when dealing with fire pumps. In a typical electrical setup, service conductors bring power from the utility company to the building. These conductors are generally required to be installed outside the building or underground, as stated in NEC section 230.1. A, which says that service conductors shall be installed outside the building or underground unless otherwise permitted in this code. However, there are exceptions and specific scenarios that can lead to differing interpretations, such as when a lug tap is used to supply a fire pump. A lug tap is a connection made to the main service conductors within a building, typically to supply a specific load, such as a fire pump. The question then becomes, is this lug tap considered a service conductor, or is it a feeder? A feeder is defined as a set of conductors that extend from the service equipment to a subpole or a specific load. Feeders are permitted to be tapped to form a branch circuit, as outlined in NEC section 210.19. A, which says that feeders shall be permitted to be tapped to form a branch circuit. If the lug tap is intended to supply only the fire pump and is located within the building, it can be argued that it is a feeder and not a service. However, local electrical inspectors may interpret the NEC differently, often prioritizing safety by requiring all service conductors to remain outside the building or encased in concrete. To navigate this situation, firstly, it's crucial to understand the key factors that influence whether a lug tap is considered a service or a feeder. These factors include purpose, location, and current rating. The purpose of the tap: is it intended to supply the entire building or only a specific load? If the tap is solely for the fire pump, it leans towards being a feeder. The location of the tap: is it located outside or inside the building? A tap inside the building is more indicative of a feeder. And finally, the current rating: is the tap rated for the total connected load of the building or just a specific portion, such as the fire pump? A rating specific to the fire pump suggests a feeder. Secondly, to resolve a disagreement with an electrical inspector, several steps can be taken. Begin by thoroughly reviewing the relevant sections of the NEC. Pay close attention to the definitions of service conductors and feeders, and any exceptions that may apply to your specific situation. Consult with a qualified electrical professional, such as a licensed electrical engineer or a master electrician, to get their expert opinion on the correct interpretation of the code. Engage in a constructive dialogue with the inspector to explain your interpretation and the reasons behind your installation. Provide any documentation, such as engineered drawings or load calculations, to support your claim that the lug tap is a feeder. Thirdly, if necessary, obtain an engineering analysis to further support your position. A professional engineer can provide a detailed assessment of the electrical system, confirming that the lug tap meets the requirements for a feeder and does not compromise safety. In the engineering analysis, consider the following aspects. Firstly, conduct a load calculation to determine the actual load served by the lug tap. This calculation should demonstrate that the tap is only supplying the fire pump and not the entire building. Secondly, provide a detailed description of the overcurrent protection devices in place. Ensure that the tap is properly protected by circuit breakers or fuses that are sized appropriately for the fire pump's load. Thirdly, include a diagram showing the physical layout of the electrical system, highlighting the location of the service conductors, the lug tap, and the fire pump controller. This diagram should clearly illustrate that the tap is located within the building and is supplying a specific load. Fourthly, cite relevant sections of the NEC that support your interpretation. For example, reference section 210.19. A, which allows feeders to be tapped to form branch circuits. Fifthly, address any potential concerns raised by the inspector regarding safety. Explain how the installation meets or exceeds the safety requirements of the NEC. If all attempts to reach an agreement with the inspector fail, the next step is to consider filing an appeal with the appropriate authority. This process typically involves submitting a formal written appeal, along with supporting documentation, to a local or regional board responsible for interpreting and enforcing electrical codes. In the appeal, clearly state your interpretation of the NEC, the reasons why you believe the lug tap should be considered a feeder, and any supporting evidence, such as engineering analyses or expert opinions. Be prepared to attend a hearing or meeting with the appeals board to present your case and answer any questions they may have. While pursuing these steps, it is essential to ensure that the electrical installation remains compliant with all applicable codes and regulations. This may involve making temporary modifications to the system, such as providing additional overcurrent protection or installing a temporary disconnect switch to address the inspector's concerns while the dispute is being resolved. Always document any changes made to the electrical system and keep a record of all communications with the inspector and the appeals board. Remember that electrical installations should always comply with applicable codes and regulations to ensure safety and proper operation. Understanding the NEC, engaging with the inspector, obtaining engineering analysis, and if necessary, filing an appeal are all vital steps in resolving disputes and ensuring a safe and compliant electrical system. It is important to delve deeper into the specific requirements and considerations for fire pump installations, as they often have unique provisions within the NEC. Fire pumps are critical for life safety and are subject to stringent regulations to ensure their reliability during emergencies. Firstly, let's examine the NEC requirements for the power supply to fire pumps. Section 695.3 of the NEC outlines the acceptable sources of power for fire pumps, which typically include a service connection or an on-site power source such as a generator. The power source must be reliable and capable of supplying the fire pump's full load. Secondly, overcurrent protection for fire pump circuits must comply with NEC Section 695.5. The overcurrent protective devices must be sized to allow the fire pump motor to start and run without tripping under normal conditions, while still providing protection against short circuits and ground faults. Thirdly, the wiring methods for fire pump circuits must be installed in accordance with NEC Section 695.6. The wiring must be mechanically protected and have a fire-resistant rating of at least 1 IR. Mineral insulated cable is a common choice for fire pump circuits due to its fire-resistant properties and durability. Fourthly, the location of the fire pump controller is also critical. NEC Section 695.4 requires the controller to be located as close as practical to the fire pump and protected from physical damage. The controller must also be readily accessible for inspection, testing, and maintenance. Fifthly, the transfer of power to the fire pump in the event of a power outage is governed by NEC Section 695.7. If the fire pump is supplied by both a normal power source and an emergency power source, such as a generator, an automatic transfer switch, or ATS, must be used to automatically switch to the emergency power source when the normal power source fails. Sixthly, regular testing and maintenance of the fire pump are essential to ensure its reliability. NEC Section 695.12 requires periodic testing of the fire pump and its associated equipment, including the controller, motor, and power supply. The testing must be performed in accordance with manufacturer's instructions and applicable codes and standards. In addition to these specific requirements for fire pumps, there are also general requirements for electrical installations that must be followed. These include proper grounding and bonding, conductor sizing, overcurrent protection, and wiring methods. It is essential to consult the latest edition of the NEC and any applicable local codes and standards to ensure compliance with all requirements. Now let's consider some practical tips for installing a lug tap for a fire pump. Firstly, carefully plan the location of the lug tap. Choose a location that is easily accessible and provides adequate working space. Ensure that the tap is located within the building and is protected from physical damage. Secondly, use appropriate connectors and fittings. Select connectors and fittings that are specifically designed for making lug tap connections. Ensure that the connectors are properly sized for the conductors being used and are installed according to manufacturer's instructions. Thirdly, properly torque all connections. Use a calibrated torque wrench to tighten all connections to the manufacturer's specified torque. This will ensure a secure and reliable connection. Fourthly, label all conductors and equipment. Clearly label all conductors, conduits, and equipment associated with the fire pump circuit. This will help prevent confusion and ensure that the system is properly maintained. Fifthly, document the installation. Keep a detailed record of the installation, including the location of the lug tap, the type of connectors used, the torque values applied, and any other relevant information. This documentation will be helpful for future maintenance and troubleshooting. In summary, when installing a lug tap for a fire pump, it is essential to carefully consider the NEC requirements, local codes, and best practices. By following these guidelines, you can ensure a safe and reliable installation that complies with all applicable regulations. Let's discuss the importance of coordination studies in electrical systems, particularly when dealing with critical loads like fire pumps. A coordination study is an engineering analysis that evaluates the protective devices in an electrical system to ensure that they are properly coordinated to minimize downtime and prevent cascading failures. The goal of a coordination study is to ensure that the protective device closest to a fault or overload will trip first, isolating the problem and preventing it from affecting other parts of the system. This is particularly important for fire pumps, as they must remain operational during emergencies. Firstly, the coordination study typically begins with a review of the electrical system's single-line diagram and equipment specifications. This includes information about the transformers, conductors, protective devices, and loads connected to the system. Secondly, the study involves calculating the available fault current at various points in the system. This information is used to determine the appropriate settings for the protective devices. Thirdly, the protective devices, such as circuit breakers and fuses, are then evaluated to ensure that they are properly coordinated. This involves comparing the time current curves of the devices to ensure that the device closest to a fault will trip first. Fourthly, the coordination study also considers the impact of motor starting on the protective devices. Large motors, such as those used in fire pumps, can draw a significant amount of current when they start, which can cause nuisance tripping of the protective devices. Fifthly, the results of the coordination study are documented in a report that includes recommendations for the appropriate settings for the protective devices. The report should also include time current curves showing the coordination between the devices. Sixthly, the coordination study should be reviewed and updated periodically, especially when changes are made to the electrical system. This will ensure that the protective devices remain properly coordinated. In the context of a fire pump installation with a lug tap, a coordination study is essential to ensure that the fire pump will remain operational during a fire. The study should consider the following factors. Firstly, the available fault current at the lug tap. Secondly, the coordination between the overcurrent protective devices for the fire pump and the upstream protective devices. Thirdly, the impact of the fire pump motor starting on the protective devices. Fourthly, the need to minimize downtime in the event of a fault. By conducting a thorough coordination study, engineers can ensure that the fire pump is protected against overloads and short circuits, while also minimizing the risk of nuisance tripping and ensuring its reliable operation during emergencies. Another important aspect to consider is the selective coordination requirements in the NEC. Selective coordination means that only the overcurrent device closest to the fault should open, minimizing the impact on the rest of the electrical system. NEC Section 700.27 and 701.18 require selective coordination for emergency and legally required standby systems, respectively. While fire pumps are not explicitly mentioned in these sections, it is generally considered good practice to apply selective coordination principles to fire pump circuits as well. To achieve selective coordination, the time current characteristics of the overcurrent devices must be carefully coordinated. This typically involves using fuses or circuit breakers with different time delay characteristics. For example, a fuse with a longer time delay can be used upstream of a circuit breaker with a shorter time delay. This will ensure that the circuit breaker will trip first in the event of a fault, while the fuse will only trip if the fault persists or is of a higher magnitude. Selective coordination can be challenging to achieve, especially in complex electrical systems. It often requires the use of specialized software and expertise. However, the benefits of selective coordination, such as minimizing downtime and preventing cascading failures, are well worth the effort. In the case of a fire pump installation with a lug tap, selective coordination would ensure that a fault on the fire pump circuit would not cause the upstream overcurrent devices to trip, potentially interrupting power to other critical loads. This is particularly important in buildings with emergency or standby power systems, where the fire pump must remain operational during a power outage. Furthermore, it is crucial to ensure that the electrical system is properly grounded and bonded. Grounding and bonding provide a low impedance path for fault current to flow back to the source, which helps to quickly clear faults and minimize the risk of electric shock. NEC sections 250.4 and 250.8 provide detailed requirements for grounding and bonding electrical systems. In the context of a fire pump installation with a lug tap, proper grounding and bonding are essential for ensuring the safety of personnel and the reliable operation of the fire pump. The grounding system must be designed to effectively clear faults and prevent dangerous voltage levels from developing on metal parts of the equipment. The bonding system must ensure that all metal parts of the electrical system are electrically connected, which helps to minimize the risk of electric shock. In addition to these technical considerations, it is also important to communicate effectively with the local electrical inspector. The inspector is responsible for ensuring that the electrical installation complies with the NEC and local codes. It is helpful to have a clear understanding of the code requirements and to be able to explain your interpretation to the inspector. If there are any disagreements or concerns, it is best to address them proactively and to work collaboratively to find a solution that meets the code requirements and ensures the safety of the installation. Remember that the ultimate goal is to ensure that the electrical system is safe, reliable, and compliant with all applicable codes and regulations. By following these guidelines and working collaboratively with the electrical inspector, you can achieve this goal and ensure the safe and reliable operation of the fire pump. In conclusion, the installation of a lug tap for a fire pump requires careful consideration of the NEC requirements, local codes, and best practices. It is essential to understand the distinction between service conductors and feeders, to properly size and protect the conductors, to conduct a coordination study to ensure selective coordination, and to communicate effectively with the electrical inspector. By following these guidelines, you can ensure a safe and reliable installation that complies with all applicable regulations and provides reliable fire protection for the building. Another aspect to consider is the labeling and documentation of the electrical system. Proper labeling and documentation are essential for ensuring that the system can be easily maintained and operated. NEC Section 110.22 requires that all electrical equipment be clearly and durably labeled with its voltage, current rating, and other relevant information. In the context of a fire pump installation with a lug tap, it is important to label all conductors, conduits, and equipment associated with the fire pump circuit. This includes labeling the lug tap itself, the overcurrent protective devices, the fire pump controller, and the fire pump motor. The label should be permanently affixed and easily readable. In addition to labeling, it is also important to maintain accurate documentation of the electrical system. This documentation should include a single-line diagram of the system, equipment specifications, and any calculations or studies that were performed. The documentation should be kept in a safe and accessible location. Proper labeling and documentation can save time and effort during maintenance and troubleshooting. It can also help to prevent mistakes and ensure that the system is operated safely and efficiently. Furthermore, it is essential to ensure that all personnel who work on the electrical system are properly trained and qualified. Electrical work can be dangerous, and it is important to have the knowledge and skills necessary to perform the work safely. NEC Section 110.3 requires that electrical equipment be installed and used in accordance with its listing and labeling. This means that only qualified persons should perform electrical work. Qualified persons are those who have the skills and knowledge related to the construction and operation of electrical equipment and installations and have received safety training to recognize and avoid the hazards involved. In the context of a fire pump installation with a lug tap, it is important to ensure that the electrician performing the work is properly licensed and qualified. The electrician should have experience working with fire pump systems and should be familiar with the NEC requirements for these systems. It is also important to provide ongoing training to personnel who work on the electrical system. This training should cover topics such as electrical safety, grounding and bonding, overcurrent protection, and fire pump operation. Regular training can help to ensure that personnel are up to date on the latest codes and best practices. In addition to these considerations, it is also important to be aware of any local amendments to the NEC. Local jurisdictions often adopt amendments to the NEC to address specific local conditions or to enhance safety. It is important to consult with the local building department or electrical inspector to determine if there are any local amendments that apply to the fire pump installation. Local amendments can vary widely, and it is important to be aware of them to ensure compliance with all applicable regulations. Some common types of local amendments include requirements for additional overcurrent protection, enhanced grounding and bonding, or specific wiring methods. Finally, it is important to remember that the fire pump is a critical life safety system. Its reliable operation is essential for protecting building occupants in the event of a fire. Therefore, it is important to take all necessary steps to ensure that the fire pump system is properly designed, installed, and maintained. This includes following all applicable codes and regulations, using qualified personnel, and providing regular testing and maintenance. By following these guidelines, you can help to ensure that the fire pump will operate reliably when it is needed most. Let's explore the requirements for emergency systems and their interaction with fire pump systems. Emergency systems are designed to provide power to essential loads during a power outage, ensuring the continued operation of critical equipment and systems. NEC Article 700 covers the installation and requirements for emergency systems. Fire pumps are often considered part of an emergency system, as they are essential for life safety. However, fire pumps also have their own specific requirements in NEC Article 695. Therefore, it is important to understand how these two articles interact. Firstly, emergency systems must have a reliable source of power, such as a generator or a battery system. The power source must be capable of supplying the emergency loads for a specified duration, typically several hours. Secondly, the emergency power source must automatically transfer to the emergency loads in the event of a power outage. This is typically accomplished using an automatic transfer switch, or ATS. Thirdly, emergency systems must be designed to minimize the risk of failure. This includes using redundant components, providing overcurrent protection, and ensuring proper grounding and bonding. Fourthly, emergency systems must be regularly tested and maintained to ensure their reliability. This includes testing the emergency power source, the automatic transfer switch, and the emergency loads. In the context of a fire pump installation, the fire pump may be connected to the emergency power system. This ensures that the fire pump will continue to operate even if the normal power source fails. However, it is important to note that the fire pump has its own dedicated power source requirements in NEC Article 695. These requirements may be more stringent than the requirements for emergency systems in general. For example, NEC Section 695.3 requires that the fire pump power source be reliable and capable of supplying the fire pump's full load. This may require a dedicated generator or a separate service connection. Additionally, NEC Section 695.7 requires that the transfer of power to the fire pump be automatic and occur within a specified time period. This is typically accomplished using a dedicated automatic transfer switch for the fire pump. In some cases, the fire pump may be connected to both the normal power source and the emergency power source. In this case, a transfer switch must be used to automatically switch to the emergency power source if the normal power source fails. However, it is important to ensure that the transfer switch is properly sized and coordinated to handle the fire pump's load. It is also important to consider the potential for the fire pump to draw a large amount of current when it starts. This can cause voltage dips and potentially affect other loads connected to the emergency system. Therefore, it may be necessary to provide additional voltage support or to use a soft start device for the fire pump motor. Furthermore, it is important to coordinate the overcurrent protection for the fire pump with the overcurrent protection for the emergency system. This will ensure that a fault in the fire pump circuit will not cause the entire emergency system to shut down. In summary, the interaction between emergency systems and fire pump systems requires careful consideration of both NEC Article 700 and NEC Article 695. It is important to ensure that the fire pump has a reliable power source, that the transfer of power is automatic and occurs within a specified time period, and that the overcurrent protection is properly coordinated. By following these guidelines, you can ensure that the fire pump will operate reliably during a power outage and provide critical fire protection for the building.